Welcome to Fast Metal. My name is and I will try to be your host. Please let me know if you can hear me.
Yes.
Okay, great. I'm actually not belonging to this institution, to this company. I'm a researcher, senior researcher with National Institute of Materials Physics, but we collaborate tightly and we try to help the company, and also we try to think what we should do in the future. Here is our director, Costina Apostol, Dr. Costina Apostol.
Yes.
She's an engineer in metallurgy and general director of this company. So I will try to introduce about the company. Probably there will be a lot of interesting discussions and questions afterwards. I hope it will be interesting. We are also planning to make a visit inside the factory. It will be a little in the nature, outside, in this sunny, beautiful weather. So sorry about that, but I hope it will be possible and you will have this opportunity. I would like also to say that yesterday evening it was very pleasant to meet some of you. So thank you very much, especially to the Bulgarian team, because they adopted us, me and Costin. So we had interesting discussions, and for example, we learned that they visited the city, and the ladies made 20,000 steps, while the men made 16,000 steps. And I think it's not because gentlemen are more lazy than the ladies. The explanation was that the steps are larger. So you can see here, and I would like to emphasize this idea, it depends on how you look on the problems, from which side, and every time, of course, there might be surprises and interesting viewpoints. I think this Interreg project, it is very useful. I think it is very interesting. And yesterday with Costin, after the party, we were a little bit in a kind of good mood, of course. And one issue here was that, of course, we are from different regions. Of course, we are from different organizations, private, state, administration, and so on. But me, science, and so on. But the idea, I think, is that we need to come together. We need to try to make some kind of exchanges, sharing. We need to put all this kind of effort further and to see how and what would be useful for each of us, and together to try to push in the progress direction, in the right direction, so that we minimize the bad effects and we maximize the efficiency and, let's say, good. So I think this type of Interreg projects are very nice, and I hope that there will be some continuation of this type of project. I also think that this kind of project can be a hub for all of us to continue to interact and to try to build something useful and interesting. Now I will try to introduce you a little bit, few images from Asmetal. So just a video for the beginning. Well, it is in Romanian language, but I think images are pretty clear. Okay, so this was a brief introduction to the factory, and let me try to give you some flavor about some details of what we are doing, what we are planning to do, and of course our vision about what and how we should try to accomplish. So here are some contact data. I think it will be interesting to have them, but of course you can always ask us afterwards when possible. Okay. This will be my presentation. Few aspects concerning the factory history, then some aspects of circular economy because we are interested in this subject. Then how is this factory positioning itself from the viewpoint of sustainability and certifications, and then strategic projects developed by this factory. At the end, some details and calculations, predictions concerning the decarbonization plan of the factory and some conclusions. So first of all, let me try to say that this is a medium-sized company specializing in recycling of aluminium. So this is a main goal, but it is also interested, of course, aluminium in a larger concept, in the idea of different alloys, and it is doing a lot of effort in this direction. It was founded in 1993, and it joined in 2009 this Italian large group. And of course the company has certifications and all kinds of necessary documents for its activity. Asmetal is not only trying to provide some production of secondary aluminium, but it's also trying to develop some recycling solutions. And this is for urban waste, but also for industrial waste. So when we talk about this kind of things here, of course, the landscape is very large. So it's not easy actually to cover everything. And in some cases, you need specific solutions. And this is where we are trying to do our best so that we can accommodate in our factory different types of waste. You'll see here are some examples of what we would like to use as a raw materials for our production. And you can see that it's a very large, very different types of waste. Now, this of course is important, but at the same time we should think in terms of our own waste, because any production, of course, it's making some product, but is making also some waste. And because of that, of course, we are also thinking inside the factory how and what to improve so that we can have less residues by our own production. So simply speaking, we are, of course, in general terms of economy, according to the diagram, we are positioned in this part, and we are in principle on this line of recycling. So what we are doing recycling. But recycling, it means actually production, fabrication. I am emphasizing that because in some cases, in some discussions, people understand by recycling collection, no, collection is collection. It's here, and after that, what you do to come back into the circular economy. So, primary goal is this one, but secondary goal is, of course, inside the factory to have also this kind of idea of local recycling. To do that and to make that decarbonization and to achieve the numbers imposed by European Union through the Green Deal, we need to do that. So we need to look at our factory, at our production and all the fluxes inside. And of course, you know this diagram with scope 1 to 3, and we have to think for each scope how to improve and how to make lower footprint for carbon. Now, a few things about the factory. The factory and the company was successful in implementing and making some projects concerning sustainability. So it was successful to approach this so-called gold standard. It is an international organization which is providing certification. You can see here what it's about. It's written. So in general, things are in terms of CO2 equivalent emissions. And Asmetal is certified by the gold standard. And it's interesting that this kind of organization is also providing some certificates, so green certificates. So the company received this number of certificates in the first 3 years. And in the next 3 years, we are expecting also next number of voluntary carbon certificates. And there is a market for this type of certificates. Unfortunately, this market is still very at the beginning, I would say. So it's not easy to manipulate this kind of things yet. I hope it will improve, and this will be useful because this can be done and can be used, of course, for improvement of the some funding for some activities in the factory. Okay, another one is this kind of carbon disclosure project. It's again similar to the previous one in some extent. There are some differences. Actually, this is a kind of reporting platform. So it's not just a project, it's a kind of continuous reporting and monitoring. And again, Asmetal is part of this kind of process. So it's reporting to this organization since 2022. And of course here things are also interesting in the sense that this is an open platform. So it's interesting in the terms of to follow and to see how the company is doing. So it helps a lot in commercial partners seeking in some kind of, let's say, equivalence in some cases. In some cases, it's giving also some extra opportunities due to this kind of platform. Yes, and it's very, very used by car industry. So from this perspective is very, very interesting. Okay, another one is this EcoVadis. Again, a kind of platform. But this one is making ratings. So it's trying to assess the quality of the process in terms of decarbonization, and then it's providing ratings. And Asmetal, you can see here, in 2019 was awarded silver medal. And this platform is also much concerned with environmental protection. So there are some different aspects each platform is trying to emphasize. Now we are moving to next section, and here I would like to talk a little bit what and how we would like to do in the future, what is going on right now, so what we are working on, and of course the main target is aluminum. And among the projects successfully implemented was this one, in which it is necessary to try to, as I said, to design and implement some innovative technological line which can give you the possibility of recovery of aluminium from very different types of waste. This is not easy, and actually today you will see also, for example, yesterday you have heard a presentation from Returo. Returo is collecting a lot of materials. Some of those materials are coming to this factory. And of course the problem is how this collected material is matching what we need for the production. So we need to adapt, and we need technology. So this kind of project was implemented to try to be as close as possible or as flexible as possible so that we can accommodate, you can see here, all kinds of things, caps, canes, foils, capsules, medical blister, chips, and many, many other things. It's not easy, and it's quite demanding. On the other hand, this project also was concerned with what to do with the waste we have in the factory. So in some cases, internal loop of recycling was also trying through this project to adapt to what we are doing. Well, just to see some kind of example here, this is an input and this is an output. Can it be better? Of course, it can be better. But at least it's relatively convenient and useful for production. Okay, for decarbonization, we are also following the processes in our country. And one of the issues here is energy. Heating is done with gas. And of course, you burn the gas and you are getting some exhaust. And this exhaust, the question is, first of all, how to control it, and second is what to do with it. So if you are thinking in terms of control, then there was a project and implemented successfully in the factory, which is based on the real-time analysis to try to see these exhaust gases, what are they, and this helps also to optimize the process, technological fabrication process. It also, of course, helps to decrease the emissions of CO2 and other unwanted gases. There is a component here which is related to energy. And it's written here, 30% of energy is lost through the furnace exhaust. So now this project, we try to go on the next level and to think of some recovery systems. We also, of course, concerned with treating and filtering this kind of exhaust gases. I would say that it's not simple, and again, it's a very, how say, demanding. Each time you make production, each time you face different raw materials, each time you have to adapt. So this is a very, how say, not specific fixed issue. It is with a lot of variation, so not so easy. But we also, and later you will see also some other ideas of how to use this waste, especially the black carbon, which we are collecting from this type of exhaust gases. As you have seen in the video, we are using forklifts and different machines. Of course, one simple idea would be to use these machines based on electric. So switch to electric cars, electric equipment, so that this will help decarbonization. Renewable sources and things like that are also of interest. And in fact, I think the next project is about, next project is we plan to install on-grid photovoltaic power plant, and this would help us a lot in terms of energetic stability, but also in this idea of decarbonization. I think it's clear here. I would move to the next one. Of course, when you are doing metallurgy and melting, you will end up with some slag. And the big question here, what are you going to do with this slag? Of course, one possibility is remove it, but again, you have the problems and concerns of how to remove it. Then the idea would be to try to see here some opportunity. After all, slag is also another kind of material, usually oxides, and these oxides might be interesting for different things. So here we are collaborating a lot, and we try to find solutions to understand this kind of materials, what they are interesting and useful for, trying to transform them into new materials or new products. We can talk about the slag, of course, but we can also talk about other types. After separation, for example, we still have a lot of other plastics, wood, and other types of materials which are not useful in our production, but at the same time the question is what to do with them. Of course, this kind of idea has a lot of impact in the terms of reduction of industrial waste quantities, avoidance of final disposal, of course with direct benefits for soil and groundwater, replacement of raw materials, so to improve and to avoid impact on natural resources, and closing of the recycling loop concerning circular economy principles. And it's a question also to be responsible, after all. We want something, if we do something, we want also to be as much as possible clean and green. So here, for example, we are exploring new ideas related to slag, but not only, as I said, and other residues from the factory on our processing. And we are seeking and looking for opportunities to use these materials in construction, chemical industry as catalysts, machinery manufacturing, in some cases for tools and blades, for example, because they are oxides and some of them are very hard. They have very good mechanical properties. Of course, automotive industry, in some cases, combining previous ideas, such as filters or other kind of things. And of course, it's also interesting in some cases this material can be used for electrical equipment, sensors, and so on. So here, for example, is one example in which slag is transformed. There is a process of agglomeration, and this kind of agglomerated particles, actually they are not particles, the sizes are in the range of 2 centimeters. They are excellent materials, for example, to be used in the metallurgy, so for iron processing, in the melting of iron, you need on the top of the molten material, you need some protection. And this protection can be done, for example, with this type of material, which is actually the slag. It's a residue from our production. And here, as I promised you, for example, here we are trying to see the black carbon, so from the exhaust. We try to see if and how we can use it. And here it's an example of a pressure sensor. So this material is pretty nice and pretty good for pressure sensors. So this can be one interesting solution. And I should say that this material here, for example, it's used as obtained from filtration, no processing. Very good. Okay. So technologically, concerning materials, concerning technology and materials, there are several things. These are only 2 examples. We are trying to look at other things as well. But I should go further and say that we are also looking at how the flux, different fluxes, energy, materials, and also the financial flux, so this type of things, and data, of course, how they can be put together, improved, optimized. And in this regard, for example, here there is this project to try to implement so-called SCADA, supervisory control and data acquisition system. And the main goal is to achieve real-time control of the consumption of resources, electricity, natural gas, water, and fuel. So it's about making some smart databases which can help us in real time to monitor what is going on. Of course, this can help us also to think and make some predictions, and this is also very important for us. And of course, digitalization, because again, we are trying to come into this, closer to this kind of modern way of doing things. We are using artificial intelligence for this kind of databases for analysis. So we try to, as I said already, to monitor, to make automatization, control, and so on of our operational processes. At the same time, we need increasing of traceability. This is one issue very important, and this will give you us better precision in understanding what and how it's working. So I think with this kind of things we can improve and we can have a better, let's say, control of what is going on. On the other hand, it's necessary to integrate with other systems. You have data, you have databases, you have analysis. Yes, but you have also equipment, you have raw materials. So another point here is that we try also to integrate different aspects, different types of information. We also try to collect and also try to see how and what would be good to and possible to monitor and to improve with different sensors, and after that with analysis. Here it's an example of what we try to do. This is a project still at the beginning. The idea is to try to follow the path of the raw materials. So in each moment to understand and to know where we started, where we are, what is going on. And here with artificial intelligence, for example, we look for the trajectory of this kind of machine, which is actually loading the furnace. So this kind of information, of course, collected, analyzed, but at the same time it should be integrated with the economic, energetic part. So you have the material and you trace it in the factory, but this should be also connected with how much energy we consume, what kind of financial aspects are there, and so on. And we try to do that. So we have different modules, let's say, of a larger project, and we also need to make each piece of the puzzle, but then the puzzle to be integrated. And this is our plan and what we are developing. Okay, since we try all kind of things like that, and there is no recipe, so it is, how say, try and see what is working, how it's working. Of course, we are also interested in replication of these kind of ideas. If something is working, why not? Maybe it's working in other factory, in another type of process, because somehow each factory has some specifics. So we are also concerned with such kind of things, and from this point of view, of course, we also need the part of education. We need also the part of promotion and other things from this point of view. I think this kind of idea of best practices, and actually we are here to see and to observe some kind of things, it is exactly what I started at the beginning telling you, that in fact I think these are exactly the elements that can put us together at the table, and to integrate different fields and to also work together and to try to have a stronger voice, stronger lobby concerning, for example, regulations and all other things concerning the law. Right now we feel that this is somehow chaotic, somehow not well constructed in terms of what is a reality and what is a theory. There are different scenarios, and there are also different aspects concerning local aspects. Here we wrote two things. For example, one idea is, okay, we have a city, and cities should be green, should be clean, but at the same time, we should not forget that cities are producing waste. And you can put the factory somewhere close to the city, and this will be one discussion, or you can put it very far from the city, and it will be a totally different discussion in terms of impact, money, and so on. So things like that should be also taken into consideration, and I think this type of discussion is necessary. There is also this kind of idea that, at least in Romania, and sometimes with Costin we are going to some meetings, and there is this emphasis of the urban waste, so city waste. But we should not forget that, in fact, more than 70% of the waste is industrial waste. So this is another issue that we have to keep in mind. And our experience and our ideas maybe can be useful in some in some cases, and some models might be also translated perhaps in other cases. Here is a carbon footprint of the company, of the factory in the last 5 years. All these measures you have seen, all these projects, they start to provide effect, positive effect. So you can see here scope 1, 2, 3 and total. And in some areas there is already a trend to go down with the carbon amount, which is very good. And in fact, we have a prediction for how, if all these projects are implemented successfully, for how we should arrive at the level of 2050 with decarbonization. So this is a kind of, let's say, general overview, but of course it can be improved. Of course there are details that will pose some problems. We will need solutions. It's a process which is ongoing. So this is a prediction, it's not. On the other hand, as you know, at the European level, this is becoming a kind of landmark. We want, we don't want, we like, we don't like. These are the targets. So this is connected to this kind of 1.5 degree scenario of climate warming. So this is coming. We need to take measures and we need to work hard together in this direction. Here it's, let's say, a kind of a summary of this decarbonization plan of this factory for that prediction, with some numbers. Of course, some measures are more efficient than the others, but ultimately I think in such kind of approach, even small things can make a big difference. I will not insist. If you are interested, of course, we can discuss more and share this information. And we are arriving at conclusions. So these projects from Asmetal, I think they are clearly contributing to decarbonization. At least internally, we already see some effects, which is, I think, good. There are things concerning and showing, of course, good intent in the sense of sustainability. So this kind of post-consumer, pre-consumer waste management and other things in European taxonomy. I think Asmetal is, let's say, a possibility and opportunity at the same time to explore and to propose new products and solutions, not only for this industry, but also for other industries. We talked about car industry, so I think, for example, in that area. There are some good practice models in the frame of the circular economy and so on. And this can be probably replicated also. So I invite you also to think in this direction. And we need active, constructive, strong collaboration with everybody. So I stop here. Thank you very much. If any questions, please.
So in terms of capacity, can you, for instance, recycle all the aluminum that is collected in Bucharest, or also outside, from outside the city?
Aluminiu nu este aluminiu, sunt sute de alieși.
Yeah, so one issue here is that when we talk about aluminium, we are not talking about one element. We are talking about alloys. And in aluminium alloys, at least according to standards, we have 8 types or 8 groups of aluminium alloys.
Dă-mi o doză de aluminiu. Spre exemplu, dozele de aluminiu.
So let me show you a can. They are looking for a can. I think everyone knows.
Care este alcătuită din aluminiu, zicem noi.
And everyone is telling, look, this can is made of aluminium. For example, Coca-Cola can.
Atunci există o parotă care zice, dom'le, avem doze vechi și partea asta doze noi, prin reciclare.
So the discussion is, for example, if we use it, it's like saying, okay, we have an old can, but then if we recycle, we arrive to a new can, which will be used.
Fals.
This is not true.
Pentru că corpul dozei este un alieș.
Because this can, it's actually a complex material. So the body is one alloy.
Este un alieș de aluminiu mangan.
So it is actually aluminium with manganese.
Iar capacul
While the cap,
este un alieș de aluminiu magnez.
it's a totally different alloy. It's aluminium magnesium.
Corpul trebuie să reziste la presiune.
So the functionality of these two parts is different. So this should withstand pressure,
Și să fie foarte maleabil.
and it should be, of course, easily to be made into such shape. So it should have ductility.
Iar capacul trebuie să ne permitem să-l rupem.
While the cap is opposite, it should be brittle so that you can easily open it.
Dacă ar fi capacul din aceeași material,
If you would make the cap from the same material as the body,
noi n-am putea să facem asta.
you cannot do this. You cannot open it.
Este evident că în momentul în care eu le topesc,
When you melt this,
voi obține nici aliajul
you will
cu
not
magneziu,
get no cap as a material, no
Mix.
body as a material. It will be a kind of
ok?
mixture.
Un mix. Și atunci ele urmează în metalurgie procese ulterioare
So after that, you have this melt and you need to process it metallurgically.
din care fabricăm tablă,
And so even if you, after that, you arrive to a certain alloy,
lamină.
you still need to make foils, yes, metal foil sheets.
Și ulterior, scanner.
And at the end, you arrive to this shape,
Scanner și
which you
capac.
know as a cap for can and the body for the can, and then you have to assemble them. So you see, apparently you have aluminium, but in fact, situation is complex.
Pistoanele de la motoare,
If you look at the pistons from the engines,
aluminiu.
it's also so-called aluminum,
Nu e același tip de aluminiu.
but it's totally different alloy.
Rezistă la temperaturi
Deci
un aliaj aluminiu-nichel.
It is aluminium nickel and it should withstand high temperatures.
Noi în Asmetal
So our factory,
producem substanțele
we are making all these alloys
pe care industria le cere.
and we are producing depending on demand from industry, different industries. Coca-Cola, for example, or car industry.
Coca-Cola vinde băutură. Ambalajele le face altcineva.
And again, we should also understand that Coca-Cola, for example, you look and say, oh, I am taking the juice. No, Coca-Cola is making only the liquid. It's not making the can. Somebody else is making the can from our materials.
La Coca-Cola ajung dozele fără capac.
So Coca-Cola receives only the body and the cap, separate.
Se toarnă Coca-Cola.
They introduce, they pour the liquid, and then they fix the cap.
Deci, în Asmetal reciclăm foarte multe substanțe, da? Recuperăm substanțe pentru diverse industrie.
So the idea is we try to focus on providing different aluminium alloys for different industries, depending on demand, but taking the waste of any kind and any type
Deci noi,
containing aluminium.
noi suntem
Alloys.
interesați, o să vedeți, de compozițiile chimice și de producția de aliaj.
Yeah, so we're always concerned with chemical composition, and of course chemical composition provides information about those alloys. So you have seen in the presentation there were some images concerning measurements and microstructural and compositional measurements of the materials we produce.
Ceea ce este interesant este proiectul Returo, puteți vorbi cu colegul, care strânge materiale. Suntem noi care reciclăm.
So you can also talk with a person from Returo. So they are getting materials, they are collecting them, and then they are providing these materials to us.
Nu suntem noi singurii care facem
And
această
we
operațiune.
are not the only people in Bucharest or in the market that are taking those materials and trying to use them to produce those alloys.
Ei, parteneriatul public-privat, în cazul Returo,
So in their case, there is a alliance in private and state public partnership in their case.
mai ales că proiectul Returo a plecat de la un studiu efectuat cu Academia, cu ASEU. Da?
Yeah, and this kind of project, in their case, started from a study which was made by Academy of Economic Sciences.
Sau cazul nostru, tehnic, ingineresc, ca să zic așa,
While in our case, in which of course it's about engineering,
în care noi lucrăm cu institutele de cercetare pe zonă tehnică.
so in that case, on the technical part, of course, engineering, equipment, all this AI and things like that, they work with national institutes, research institutes, and in some cases universities.
Interesant că toate lucrurile astea au pornit de la nivel, nu de la nivel înalt politic, ci de la nivel de bază. Da?
And he would like to emphasize that all these initiatives, all these kind of things started from the base level, not from the top, so not from authorities. It is from.
Și atunci am văzut în Interreg o posibilitate de amplificare a acestei mișcări.
And for us, Interreg, it's a kind of opportunity. It is a vehicle that can provide for this kind of ideas a good push.
Pentru că colegii din Bulgaria, cu care am vorbit mai mult aseară, că eram vecini,
We talked yesterday more with Bulgarian colleagues,
au cam aceleași probleme.
and we learned that actually we have approximately similar problems.
Și atunci, dacă ne vom sprijini unii pe alții, cum merg în Bulgaria, cum merg oriunde e nevoie din România, lucrurile capătă mult mai multă consistență.
And this kind of visits and learning about each other can give substance to this kind of ideas and provide good opportunities.
Pentru că noi trăim în lumea reală,
We are in the real world
cu toate problemele de rigoare.
with all the problems which are there. I mean, you need to survive here.
Bun. Facem o excursie, o să vedeți ceea ce ați văzut pe film.
So what was on the movie, you will see. We will make 3 groups, I think.